Hit leave meeting, right?
What's that?
Said hit leave meeting, right?
Leave meeting. Don't touch the leave meeting button. I think we are live now. I think we're out of the waiting room and we are absolutely on the internet.
Let's do this.
So please keep it family friendly. Although I did like that joke. Um, so hi everybody. Welcome. We're going to get started here in just a few minutes. I'm going to let everybody log in. We're going to take some time to meet my friends who joined me for today's discussion, and then we will get started on our conversation about the controller hardware. Before I do that, I want to jump over to my friend TJ Rayton, who is, as I love to tell the story, a second generation on a 3-generation sprinkler guy train. He is currently developing the 3rd generation of Tom Rayton water management gurus. TJ.
Yes, sir. How's it going, Ben?
Good. How are you?
Pretty good. Pretty good.
How are things in Southern California?
I'm done for the rain. Although we need it, I'm done with it. I'm ready to start getting stuff going here.
Yeah, I've heard a lot about that rain. The people are all first they were giddy and now they're exhausted.
Yeah. I've seen
rain and snow.
I've seen pictures of people sticking their hands up out of a puddle of water, saying, "Okay, we've had enough. No more."
That's awesome. Also on the line, I have my friend Jonathan Heredia, who is the Tier 3 engineering support guy, and a heck of a training partner. He does all of my Spanish trainings when I do training events. Jonathan joins me and has run the Spanish room the last number of times. Jonathan, welcome.
Thank you for having me, Ben, and happy to be here, TJ.
Nice to have you. How are things in Northern California? Are you getting as much rain up there?
Oh yeah, it's a little dry right now. It's I think the weather's a little bipolar right now, so we'll see how things go tonight.
Jonathan, I've done a bunch of these episodes, and in fact, I think you're the first guest host who has joined me from the corporate office. So I love that I can look into your background and feel like
yes,
I'm
welcome.
there at Hydro Point.
Welcome.
I wouldn't show off too much of the desk if I were you. I'm just saying.
That's the archives, the Hydro Point Museum that you see back there.
Nice. Looks like a hardworking man desk right there.
Thank you.
Nice. And so thanks for joining me. Tell me a little bit about how you joined the Hydro Point team.
I got involved early on back in 2013. It was kind of interesting at that time because we were still working with paging technology. We didn't have a central system. When we moved to a central system, it was fun to work with. And now here we are, LTE, right? Going live, and everything's good.
If I remember, you started answering phones on the customer service team. Is that right?
I did, yeah. That's what I started off at customer service, and then from there progressed my way up. Got really involved with the hardware, and just started to pick it up and like it, and I'm still here.
Yeah. So when you transferred out of customer service, you started working for engineering. Was that for central support? You started working with Adam, right? Wasn't it?
Right. So started working with the head
rolling?
engineer at the time. From there, I then slowly transitioned, kind of like a hybrid system where I was working support along with engineering. From there, I started then transitioning a bit to operations, which I assisted there. And then now, eventually, I've kind of slowly merged over to the engineering department again. So supporting mainly all the engineers, hardware guys, software guys, and love it.
Basic, all-round WeatherTRAK stuff.
Oh yeah,
I will
all
say,
my what I call them my Hydro Point nerds. Yeah.
yeah, I call them my Hydro Point nerds. I wonder who called them that first.
Yeah, great guys, really smart. Everybody loves working with irrigation, right? And so that's what makes it fun is that we're all speaking the same language and we're having fun with it, right?
Yeah,
So.
absolutely. What I will say for those of you listening, Jonathan is the guy that when I have WeatherTRAK questions, I go to. So that he is higher on the WeatherTRAK food chain than I am. So it is a pleasure
I
to
go
have.
to I'll go to TJ from time to time for questions too. So
I was just gonna say Jonathan's on my speed dial.
So
there's
let's
very
switch over
few
to
people. There's
TJ.
very few people I reach out to, but definitely TJ is on that list.
Yes, I've learned some from TJ myself. TJ, I mentioned that you are second generation water manager. I actually
Yes,
met
sir.
your dad, the guru of water management in Las Vegas, before I met you.
Yes, sir.
Did you aim to be a water manager, or is it just in the genes?
Absolutely. I ran as fast as I could, to be honest with you. I actually remember wiring remote ribbon cables into central control systems back in the late 90s. While going through high school, I was earning extra money doing that. And when I got out of high school, I went into actually the automotive trade and got into fabrication. And I wanted nothing to do with irrigation. And then and then about 2010, I got asked to come back and help with the family business. Stuff was getting a little bit too busy for him, and I've kind of been stuck ever since. So luckily, in the position that I'm in right now, it allows me to kind of still dabble in some of the fabrication stuff. As you know, SiteOne Green Tech offers solutions for all kinds of problems. So I get to do the irrigation stuff that I was kind of brought up doing, but then I still get to throw my own twist in it. So I want to say it's kind of the best of both worlds.
Nice. And we are coming up on the top of the hour. We only have a few minutes left, but I want to hear about what you do for SiteOne Green Tech and how that all plays out. Can you tell us a little bit about your role with SiteOne?
Yeah, so I am a district sales manager. I call on cities, schools, municipalities, end users. I go out and help find solutions for their current problems, whether it be irrigation controllers in order to be able to manage their flow, booster pumps in order to be able to create pressure because they have too many stations to be able to run, or provide solar for their controllers. I mean, we do a whole slew of solutions. We call it, we're the technology gurus of the industry. So kind of fits right in with you and Jonathan there.
Yeah, but we're just caught in the WeatherTRAK world. That opens a lot of fun doors for you, especially with your background in fabrication and all the mechanical stuff that you're into.
Absolutely.
I'm
Absolutely.
sure it's a great fit.
Absolutely.
Well, I'm excited to get started. So let us go ahead and do this. It is right at the top of the hour. So let's jump right in. So first of all, hi, everyone. Thanks for joining us on Smart Water Wednesdays. My name is Ben Coffey. I'm the National Training Manager. Today, we will be talking about controller hardware. We offered a survey of our most frequent listeners, and the feedback that we got said, you guys are always talking about WeatherTRAK, but it's always focused on the features and how-to stuff. You never look at the controller hardware itself. So you're in for a treat because that's all we're going to talk about today. We are going to go and explore the hardware on the LC, the hardware on the Pro 3, and on the XR. What I touted on the tagline from last time was that this will be about the lights, the ports, and the wires that you see in the box before you install it, but after it's on the wall, right? We're not going to talk about field wires or flow sensors or anything like that. We're going to talk about the controller hardware itself. So let me jump right in. Oh, there we go. So like I said, controller hardware. And the first thing that we're going to talk about, you might have noticed that I'm at a different angle than I'm usually at. I'm still in the WeatherTRAK studios, but I have a whole host of WeatherTRAK controllers behind me, starting first and foremost with the WeatherTRAK LC. So this actually you might recognize from the mobile demos that I do, but this is actually my house, and the wires are actually my irrigation system. Ooh, before I get started, I do want to just highlight, you met him in the pre-show, but if you're just tuning in, my friend Jonathan Heredia is our Tier 3 engineering support and my co-host for today. He is a WeatherTRAK guru. Say hi to the crowd, Jonathan.
Hello, everybody. Thank you for having me.
And my guest this week is another irrigation guy from the ground up. TJ Rayton is a Site One Green Tech sales manager from Southern California. Welcome, TJ.
How's it going, Ben and Jonathan? How you guys doing today?
Doing great. Happy to have you.
It's
Right, so-
awesome to have. I'm looking at it. So I'm like, okay, this is gonna be cool.
This is gonna be cool. So I got to tell you, when I thought of talking about controller nerdy stuff, these two were the first two names that came to mind, right? So this is absolutely a treat for me because this is exactly the way I wanted this to go. So first, I want to highlight for you, this is going to be true of all of the WeatherTRAK that you get, all the WeatherTRAK LC controllers, all the Pro 3 controllers, and the XR controllers that we're going to look at have 5 main components. Unlike some other solutions that offer same feature sets, WeatherTRAK is a very simple hardware. So when we're troubleshooting in the field, it really comes down to one of 5 things. and determining what it is by design pretty simple. We give you some things to look for. You can simply figure out which part isn't doing what it's supposed to do and replace that one piece. It's all designed to be modular, and if the transformer fails, we can easily replace that. The enclosure almost never fails unless it gets hit by a truck, but it is an important part, right? That's what keeps us safe. The antenna is different on every controller. Everybody knows who just went through the LTE upgrade, that the antenna is a key part that is also modular and needs to match the modem that's in there. Finally, we get to the 2 biggies. The command module, or what we call the WeatherTRAK panel, is the brains of the network. We're not going to go into a lot of panel stuff today because that really is the features that we talk about in other episodes. What we are going to focus on is the WeatherTRAK mini chassis, the valve wire terminal board that is under that panel, and look at all the diagnostics that are available there and talk about the hardware that comes along with it. To start, we are going to go to a live cam and talk about the controller itself, but I do want to highlight that with every WeatherTRAK, in the literature that comes with the controller that you may or may not have read, accompanied with all of that packet of literature is what we call the quick reference guide, or the reference card. It's a laminated piece that comes with every controller that we send out and has the information on it that we are going to discuss today. And so you can see here, this is straight from an LC. It matches this controller. We have 2 different LCs that we'll talk about, but this is the kind of stuff that we want to focus on, right? The fuse, the connections, the keys, the LEDs. And so we'll go through it here, but know that in the field, when you get to troubleshooting, you have a resource to remind you of all of these conversations. Look in the information packet, and you will find the quick reference card. This is for 6, 12, or 18 station LC Plus. We also have a different one for a 24, 30, or 36, right? There's 2 different models of LC. The boards do look slightly different, but we're gonna just, all of the lights and connections are the same. So we're gonna just look at this one today and go through kind of one at a time exactly what each component is and does. I also want to bring this in close. You guys no longer have to be subjects to my face. We're going to zoom right in here and start at the very top. Okay, so as we come out of the transformer, so we power up behind this enclosure right here. So behind this box is in the case of the LC, a 24-volt transformer, right? It's a step-down transformer. And we see the power wires coming into the power adapter right here on the board. And the first stop is the 2-amp slow blow fuse on the LC, right? Meaning that the maximum output will be 2 amps on any individual at any time, right? Anything to say about that, Jonathan?
Power option that you have to hook that up is 110. Again, the fuse there to protect, hopefully in the event of a surge, right?
Right.
Surge event.
Ben, I would like to say if for any reason that fuse does blow, it needs to be replaced with a slow blow. It cannot be replaced with a fast blow.
Yeah, and the other
Amen.
thing too, that's a very good point, TJ. One thing to note though is if you happen to be out like at certain parts stores or whatever, right? Sometimes they might not advertise it as slow blow, but a time delay fuse. So that's one thing you want to note, and so that's important to note too when you go to purchase those. So
Absolutely. TJ, can you give me an example of what you see blowing a fuse? Like just so the listeners understand.
Maybe multiple shorts over time on the valve wires would cause a fuse to potentially blow. I mean, a direct short in the field would definitely wanna short that.
Yeah. And I see any anomalies from the power side, like anything coming in from the transformer. That's really what the fuse is designed to protect, is like if we're in an area of brownouts or some sort of anomalous
Or dirty
surge happens.
power, yes.
Right, dirty power. That's what I see most frequently blowing fuses. Jonathan, what about you?
yeah, I've seen that a lot too, or even just trying to wire up that circuit board. Even though they already come assembled, you really shouldn't have to mess with those connections. The only connections you're really worried about is your high power side, right? The high side. And so realistically speaking, a certified electrician, right, or equivalent would be performing that. So really no need to do that unless you get like a replacement for whatever reason.
Makes sense to me.
See
Awesome.
that. I do see that a lot though. They'll miswire that and thing pops.
And the other thing that I've seen a rain sensor. I don't know what it is about a faulty rain sensor, but I had a
Yeah.
rain sensor that would blow
So
a
that's
fuse.
another thing too is they'll force that upside down because you can, and that will also blow the fuse because
This
now you
guy over
created
here.
yes, yeah, you're basically shorting out
Yeah.
the circuit.
So I will get there. We'll talk about the rain sensor as soon as we get there. So we go from the power supply to the fuse, and then the first stop is the ribbon cable that powers the board, right? So what we're seeing here is the ribbon cable, and this is where it plugs in. Mine is super, super old, but it has an adapter board on there. You won't see that except on the oldest versions of the LC. Um, so we plug in the panel through this ribbon cable right there. And this is where we get to our first and second LED diagnostics. Jonathan, can you tell me what you see in that yellow light and that green light?
Yeah. So back to the conversation about power and fuses, right? This is a good time to bring this up too. We no longer need a voltmeter for these LED diagnostic lights yet. What this allows us to accomplish is that orange light, if you could point that out, Ben, right there on the top. So that actually indicates that we have 24 volts coming into the system, right, onto the circuit board, or I'm sorry, terminal board in this case. But that's what that light indicates. So Ben, if you unplug the panel,
Which side? You can.
doesn't matter. And realistically speaking, folks, we would not want to do this. This is just for demonstration purposes. We would want to first power down the controller
Right.
before we remove the ribbon cable. Best practice, because we're live, right? All right. So the other thing too. So here we'll notice that we only have a orange light, right? So this is already telling me I have that 24 volts coming in, so I don't have to probe with a voltmeter.
So if you don't have that light, tell me what that means.
That is when we want to then take out our voltmeter. Obviously, we want to, go for the lowest hanging fruit. Is my fuse blown, right? If it is, replace it with the equivalent and then work your way back.
Right. So check the fuse and then check the power source.
Correct.
Good enough. TJ?
Couple
Anything-
things on that fuse that I've seen. If you get a contractor who's got maybe rough hands, or a technician with rather large hands, they're a little rough pulling that fuse in and out. And what happens is the two little blades that hold the fuse tight end up getting a little wide, and it doesn't make a tight connection on that fuse anymore. So a lot of the times what you can do is you can kind of pinch the blades back together, get a little bit of tension on them before you put that fuse back in.
I love it. That's great.
Yeah, that's
I've
awesome.
seen that too.
That's yeah, very good.
All right, Jonathan, I'm going to plug this back in. Yeah.
Yes, correct.
Or do you want to talk about the green light first so we can?
Yeah,
what
so
it's
right
doing
here,
like-
actually, before you continue, if you once the power is applied, the way it works is it's going to receive the 24 volts, right, and then it's going to provide power to the command module or panel, right. That's where we interface with the controller, and then it's going to return that power to provide power to the rest of the circuitry. And you could see that right now when you plug it in, you'll see kind of the steps it goes through that I talked about here. So we'll see green, then green, then blue, right? So and then that is an indication that right, the panel should be powered up because I see the green light, and so on and so forth, which we will go in depth.
So let me tell you what I just saw in slow motion, and you can break it down for me. So when I plugged in that panel, I saw the green light that you've already talked about.
Correct.
Then I saw a flashing red light as it. Tell me what it was doing right then.
That could have been for the communication, or there's a few other LEDs on there that don't really get talked about too much, but those are essentially for things like flow alerts, electrical alerts, or communication alerts. Right next to it, you'll see that it's got the orange. I'm sorry, the green light, which is for the 3 volts. Then you have the flow light below that, and then you have an electrical alert light, and then below that you have a comm alert.
And those are all labeled.
And those are all
You can
labeled.
see them
and,
on the board.
Yeah. And so all of those lights indicate if it's flashing red, then there's a problem either with flow, electrical, or communication.
Right. And so as it's powering up, we saw the communication light flash just
Mhm.
because it hadn't communicated and it was telling us that it was trying to communicate.
Correct.
Right? Once it made that connection, we were all good.
Right.
After that happened, I saw in sequence these little blue LEDs come on. Can you tell me what those are?
Yeah, okay. So these are indicator lights to tell us how many stations we have available to use, right? Now, Bennett, can you do me a favor and remove the station keys? Hopefully everybody is familiar what station keys are. If you're not and you're new to this, station keys are modules that expand the controller's station count capabilities, right? So just adding more stations.
Station key.
All right. So go ahead and remove another one,
Okay.
and we will give it a little bit. Now, what we're going to notice is those 3 blue lights. See, now one goes away. We'll watch the other one go away here shortly. It'll turn off. It's about 15 seconds every time. There it goes. So now we only have 1 blue LED light. So this would represent that I have 6 available stations. Ben, can you explain the difference between the 18 station terminal board and our 36 station terminal board?
Absolutely. So the terminal board that's capable of 18 stations is what you'll find in a 6, 12, or 18 station controller. It always comes with the same board, and the keys are the modular expansion. So with 0 keys, you've still got 6 stations available as indicated by the light above the 6. If I add 1 key, boom, that is going to expand my available station count from 6 to 12. And as I add a second key, we'll go from 12 to 18.
And so we'll notice here behind the scenes, it takes 15 seconds for it to check that to see if that module is there. And so that's why you're going to see the delay, and that's perfect, right? So if it doesn't turn on immediately, don't panic. Give it a little bit, and then the light should turn on.
And then to answer your question directly, the difference, the concept is the same for the 24, 30, and 36 station. It's just a larger board that's capable of managing more stations, but it is keyed expansion. So with 0 keys, you're at 24. Add 1 key, you're at 30, and then 2 keys, you're at 36. TJ, what do these keys mean to you? This is something that I talk to distributors about a bunch.
Correct. So station keys make this easy for me as a distributor because I don't have to have 12 station controllers, 18 station controllers, 6 station controllers on the shelf. I can have a single model controller on the shelf and have station keys, and now I can update my controllers based on using a station key rather than having to have all of these SKUs in our system. It's very simple. I have a 6 station controller, and then I either add a single key or dual keys to get me to either 12 or 18 stations.
Right.
So,
and then from the user experience as well, right? You can buy a 6 station controller, and if you add on to that system, you can simply add a key without replacing any controller parts at all.
Absolutely. The idea to upsize your controller should you decide that you want to add more zones, or a customer decides that they want to add more zones. It's very easily doable.
Absolutely. All right. So that in a nutshell is all of the lights and the cables. Oh, nope. I didn't talk about the antenna cable, and it's not really coming from the board.
Can we talk about the flow light?
Oh, yeah, I was going there next.
Okay,
absolutely.
Sorry.
You're good. So
I didn't mean to take the thunder, my bad.
No, you're good. I was going to introduce the flow port and then the light and the key and the whole thing. So let's talk about flow. So the flow with an LC is an option, right? That means that, again, a key unlocks that functionality. All controllers are capable of listening to a flow sensor, but you have to have the key to unlock that functionality. So what we're talking about is this specific port right here. As we move down the board, this is where I plug in the black and red wires coming from my flow sensor. And you can see I've got that guy coming in. TJ, you would be proud. I have a Flow HD in my front yard. And right above, so this is where
have you actually gone live though?
What's that?
Is your system still winterized?
It is. It's 30 degrees and snowing in Denver today. So
who would have thought we're almost April?
So Jonathan, now that we understand the port, I want you to talk to me about the key.
Yeah, so these are all what we call smart keys. So Ben, do me a favor and pull them all out.
All of them.
All of them. So the neat thing of the LC is these are what we call smart keys. So those ports no longer depend on sequence. So you don't have to put them in order, right? You can literally put any one of those in any one of those ports, and it will recognize it, whether it's a 6 station key or if it's a flow key. And the reason we want a flow key, like Ben said, is to open up that port so it allows us to monitor the flow and, act on any alerts if they meet those conditions.
Absolutely. If you want to talk about flow, Smart Water Wednesdays has a ton of episodes on how to add a flow sensor, how to select a flow sensor, how to dial those settings in, all sorts of good stuff in the Smart Water Wednesday conversations.
TJ, can you talk about what color light the flow sensor is and, how that works, right? When it's blinking, right? Can you talk about that a little bit and how you use that in the field to help you diagnose and troubleshoot and isolate problems quickly?
Got it. Absolutely. So when I have a flow sensor hooked up, I can actually run a manual station from the controller, and I can look at the controller and I can watch the blue LED actually flash as flow comes through.
It's a white one, a little white one.
Is it white?
Yeah, a little white one. Sorry about that. But Ben, if you have a paper clip, we can demonstrate this as TJ's or not.
You're good. Keep talking. I'll be right back.
Yeah, go ahead, TJ.
Got it. So what I can do is I know whether I have a flow or not. And then I already know where you're going. So you can actually test the port on this by running what's called a tap test. What a tap test does is it basically you are shorting the two ports on the flow sensor. You can literally just put a paper clip, one in the red side, one in the negative side.
Or if
use
you're an
or use a
irrigation
piece of
tech, for
wire
sure
too.
you have 14 gauge wire just rolling around in the back of your truck.
Paper
So
clip, right?
Absolutely.
Right.
So what I'm going to do is I'm going to disconnect my flow wires. Come on, maybe.
And so TJ, this method, right, it helps us eliminate the interface, right, the command module at this point, right? Because we can quickly
Correct.
isolate, roughly within 10 to 15 minutes once on site, right? And we're talking boots on ground, performing these actions, right? So
Absolutely.
it's a really good means. So it's not just a Christmas tree, right? Like we get that a lot, like, oh, nice little, right? These lights are here to help us isolate and troubleshoot a lot faster, right? And
Correct.
so once we understand these lights, right, they help us diagnose problems.
Now, Ben, do me a favor and take those two wires and tap them together like you're Nicolas Cage in Gone in 60 Seconds. Ah, there you go. You can see the light flashing. So now we know that the hardware at the controller works.
Right.
The next step that I would do is I would go out into the field and I would actually disconnect the flow sensor, tap the field wires together at the flow sensor, and see if I have a signal back here at the controller again. That'll rule out your controller. That'll rule out your wiring path. Then you're down to one simple product, and that would be possibly a bad flow sensor.
Yeah. Yeah. I mean, you got it. I mean, right. It's really that fast, right? Whereas before, right, it was a little more involved when we didn't have diagnostic lines.
Exactly right. So awesome way to use those LEDs. Anything else on flow? Now let's talk about the rain sensor port. We already referred to it earlier, right? But TJ, can you tell me the 4 different ports that we see on a rain sensor port?
All right, so you have the two red ports, which are the 24-volt power terminals, and then you have a red and a black and a white port, which are for the rain sensor. They come factory with a jumper in it, which is going to simulate a dry situation. Technically, when you get a flow sensor, what it's going to do is when it gets wet, it's going to create an open circuit, which is going to disconnect, just like removing that jumper wire right there, and it's going to go into a rain event. Perfect. Yeah. Showing the jumper. And those are really easy to change out. They just got little quick tabs on them, pressure tabs. You can just kind of flip them up and be gentle. It's not
they are a bit difficult sometimes, but you can remove it. You don't
have to be super strong.
Right. Right. But if you are super strong, and be careful when you go to install it, because you can force it upside down. And if you do, you will blow your fuse, or potentially worse, right?
Right. But if you notice, they are shaped in a way that it only naturally fits in one way. So
exactly.
You got to just
naturally.
You don't force it. Careful how you do it.
So, why would we have 24 volts there, right? Again, for a rain sensor, there are some flow sensors that require special power, right? So that gives us a quick, easy access. And just be careful that first port is always going to be 24 volts AC live at all times when controller is powered up.
Absolutely.
I like to use that 24 volt to power my flow links.
And the flow links, yes, excellent.
Or a photodiode flow sensor if you're so inclined.
Yeah. Absolutely.
So, yeah.
I'm good on rain sensors. The last thing I want to talk about is the valve wire terminal strip, right? This is just a quick and easy, right? This is where we plug in each valve wire. I label all of my valves, so I know what wire goes to what station. Doesn't matter. I've got them all colored and labeled. I am a labeler. I love having everything labeled in that controller. TJ, talk to me about your labeling habits.
Oh, I don't touch a single controller without labeling it. It is a very easy, simple task that organizes things. If you need to take a wire out of there for some reason or not, for
One red
troubleshooting,
wire out of how
absolutely,
many?
you take the one red wire out, and then where did that red wire go? Nobody uses multi-strand. Nobody uses a different color for every wire. So
Unless you're
Going
like
commercial. This is
yeah,
a
I was gonna say
residential system.
residential. Yeah, there you
yep,
go.
yep.
Commercial,
So most of the time I show up and it's all a single color wire.
Yeah.
So
even
if
the
they're
common.
not labeled, it makes it really hard to know what's what.
In fact, the valve wire terminal strip that we're talking about is optimized for 14 gauge wire. It's designed that if you have 14 gauge wire, you can just poke it straight in and the lock will give way. With a 16 gauge wire like I have on residential grade, you have to unlock it and plug it in, and it's a little bit, it's an additional step.
Yeah, so yeah, that's a good point. If you have solid core wire, right, you could just pop that thing right in. If it's multi-strand, all you have to do is just hold that little button, and you know, no more tiny screwdrivers.
And away we go.
Yeah.
Nice. All right. So, in my estimation, we've talked about all the ports, all the LEDs, and all of the cables that we've got coming in and out of the LC. Anything LC related before we move on?
One last thing that I would like to talk about that it does fall in the category we're covering today. The one LED light we did not cover is the USB key. Ben, can you illustrate where we find
Back
that?
here, this guy.
Yes, sir. So one thing we'll note is that there is a red LED on this guy. That is normal. That's what we want to see. If it's not on, then there's something wrong with the key and or command module. Those keys help us push information over the air. And so just wanted
Hence
to
the name
point that out.
Cloud Update
Yeah,
Key.
right.
I love it. Awesome.
Mhm.
Okay, so now I am going to go back to my PowerPoint finesse. But the card, oh, let me just do this. The card is in your information kit on the back of the door of every controller that you manage. So hopefully all of this information still exists. And this laminated card has all of this information for you. So by all means, all of these conversations live on this card. Okay, so just as a best practice, use that card. Oop, don't go too. Now, to get to this board, we have to take off the panel, and this will show us everything there is to see about the Pro 3 board.
Hey Ben, can we stop there? Because you actually made a really good you hit something that might not cover this, but so one thing that I don't like going on sites, and TJ, I don't know if you can agree on this or not,
Someone
but
using a drill to use those thumb screws.
thank you, man. Oh my gosh. Yes.
Thumb
Please
screws,
don't do that.
thumb
Just
screws.
use your thumb, or if you're worried for whatever reason that it's gonna fall off, lightly, right? And I
Amen.
mean lightly
Finger
with the
tight.
screwdriver.
They're not gonna fall off. You do not
And
need
they're
a
actually,
screwdriver.
Ben, if I don't know if you could zoom in on those knobs, but they're actually textured, right? So if you do have wet hands or anything, right, you still have a hold of those. So, and it makes things just so much easier, right? If you do have to access the mini chassis, the circuitry.
And putting a screwdriver or worse, a drill on there can strip that out and make it
Yeah.
almost impossible to get
Or they'll
that
pop right
faceplate
out,
off.
right? You'll damage it, right?
You'll
And
damage
then
it. So
don't do
good point. So these are the thumb screws that Jonathan is talking about, right? They're textured on the side and easy to grab thumb screws. So please don't put a screwdriver on there. All right.
or a drill.
Or a drill, even worse, right? Okay, so the path again, 120 volt power comes in through the, oh, I gotta transfer down here, can't see it. Now we've got a step down transformer that gives us 24 volts up to the adapter on the top of the board. You'll see the red and the yellow wire coming in. This is this little protected cable that runs behind the board is what runs between the transformer and the board. So we have the power running from the transformer up through and plugging in here. If I ever have to kill the power to the board, I simply unplug that adapter, and that will kill everything on the board without having to deal with the high voltage power or tracing power. This is an easy way to kill the power going to the board.
Yeah, and the way that Ben illustrates that is very good. You want to use your fingers, right, and remove that black cube, right, that black plastic cube. Don't yank the tie wrap, right, the wire loom.
Yeah, don't grab the wire and yank. No.
Yeah.
We've actually taken it a step further, Ben, and we put a switch on all of our assemblies for serviceability, so we can actually shut our power off.
Nice.
And not have to go reaching in there.
Do that on all your even the wall mounts?
All of our controller assemblies that come from with a WeatherTRAK name on it, yes.
Perfect.
Okay, that's cool. I like that because then you can you don't have to mess with wiring or voltage at the transformer, right? That kills it before the transformer, and you can check all your transformer connections. That's great. Oftentimes, I just want to kill the board. Like if I'm plugging in a rain sensor, for example, I'll always kill the power to the board before I unplug anything or
we have to remove the panel, right? TJ, is that standard
for what? For all of our assemblies?
Yeah,
absolutely.
Through WeatherTRAK. If I go through WeatherTRAK, and then okay,
all of our WeatherTRAK assemblies come with a switch, a GFI to be able to plug in external devices. And we actually go a step further and we include a surge protector on the 110 power. So we actually
and we use that to help us mitigate dirty power.
Absolutely.
Which would cause a what, Ben?
And this is why I hired these two sprinkler nerds to come talk about this. Like, this is spot on right here.
Yeah, can we back up a little bit? Right. Sorry. We talked briefly about the LC transformer, right? Let's talk about the Pro 3 transformer a little bit, because there are some options that not a lot of people really understand. But we have 3A power options for the transformer. TJ, how has that helped you out in the field? As far as installation or obstacles that you might.
We have the option of doing 110. 208 single phase and 240 single phase. The benefits of those is when we're putting a controller next to a pump enclosure. A lot of times our pumps do not run on 110 power. They're either pulled in 208, 240, sometimes even 480. So the 208 and the 240 options make it so that we don't have to pull new power to power up the irrigation controller. We can run on that high voltage.
So deployment is way easier now, right?
Absolutely.
And that comes from the factory, right? And even better with the WeatherTRAK service, right? We get additional features, which helps us even more, right? And if you, for whatever reason, forget, hey, well, okay, which one of these colors does what, right? We do label the transformer bracket, and as well as that information is located in the manual.
So I think the 110 is standard color code, black, white, green.
Yes,
and
sir.
Then I believe that the 208 and the 240 is going to include a blue and a brown.
Yep. Yes. So brown is 2.
Blue and the brown will come capped. So you'll know right off the bat, because the 110 is the standard install, right? What we see at least 9 times out of 10 is the 110. So these are there for a special application, but they're capped, so they indicate that
they're live, they're hot,
is what you most likely will be using.
Yeah, so you want to make sure that those are always capped.
Amen. If they
like you just said, Jonathan, they are hot. So if you touch them, they will burn you.
So make sure that they're always capped.
If you don't cap them and they touch the metal cabinet, it will short the whole controller out.
Yeah,
absolutely.
So, all right, enough about transformer. Let's go from transformer to fuse. Got
Yes,
the
so
3
from
amp fuse.
transformer, right, we have it's a its limit is a 3 amp transformer, 24 volt, right? Then provides that power to the board. And when we have a three, not a 2 amp, but a 3 amp 250 volt fuse, and that is also a slow blow fuse, or in some instances, right, when we're trying to find these things in the store, a time delay fuse. Um, TJ, you got anything to add to that?
No, make sure that you do not put a bigger fuse in that. I've
Yeah,
seen customers say, "Oh, I can't
or a
find a
smaller
3 amp,
fuse, right?
so I'm going to put a 5 amp in there." And
Yeah,
what that
right.
does is the whole reason for the fuse is to be able to protect things. So if you
Right.
put a bigger fuse in there, it's no longer going to protect anything.
Exactly.
So we
Exactly.
go power, we go fuse, we go power board where we start to see LEDs. Jonathan, talk to me about that.
Yeah. So for illustration purposes and training, right? Ben, can you remove the ribbon connector? Again, we don't ever want to do this out in the field, right? Because you're more prone to
Would you like me to
um
unplug it first?
yes, sir.
Thank you. I got yelled at once, that's enough.
All
So I unplug the ribbon
right.
cable and I'll
So
plug you back
again,
in.
yep. So again, if once we have power, we're gonna see two things here. It's a bit different now. We still have the orange light on the chassis or the circuit board, right? We have one at the lower right hand side and one on the upper left hand side, right? So the way it works is the one on the right hand side, that is 24 volts coming into the controller. Again, I no longer need I'm sorry, a voltmeter at this point because this light is telling me I have good power coming in. Then that feeds the adapter board, and the adapter board is ready to fire up the command module once it's connected. But again, we want to make sure that the ribbon cable and the command module are connected to the controller before we ever apply power. That ensures that we're not going to have a surge event. So Ben, if you power down the controller
And
by
wait for that
removing,
LED to go dark is what
yep,
I do because that means all the power is off the board.
exactly. And wait, give it a little bit, reconnect the ribbon cable, make sure it's properly seated on the panel. Once it is, you're going to see 24 volt and then 3 volt, 3.5, and then that 3.5 spits that power back to the station keys, which then fire up your stations.
So, and then talk to me about the lights on the keys.
Okay. So again, a bit different than the LC, whereas the LC keys do not have LED lights on the actual keys. So the Pro 3 keys are kind of a smoky gray color. Um, and if those of our veterans on here that have any legacy products like a Pro 2 Smart Water Manager, these will look similar, right? Because they are exactly the identical. And these are our expansion modules. Once you plug them in, the blue LED light will turn on. One question I do get asked is, does it matter which way the LED faces, whether it's pointing to the left or to the right? No, it does not. There's no orientation as far as when you go to install them, but these you do have to connect in sequential order. And then, so if in this case, if I had the first two connected in the middle and last port, the controller would actually not run. The reason being is it wouldn't find the first 12 stations, right? So we always need to have at least one key in that first port. That's the minimum station count that these controllers are configured in is 12 stations. And so that first key will give us 12. And then depending on the type of controller you have, conventional controller, we modulate up with station keys.
All right. And then so that did you cover this green LED down here, Jonathan?
Yeah. So again, that indicates that the command module received basically it received good power, right?
Jonathan, what does that flashing red light mean?
That indicates that we have 3 station keys connected to this 124 station terminal board. If we had 24, right, if we had all 6, we would expect 2 flashing red lights.
Perfect. All right. So I think that covers the LEDs. TJ, do you use these LEDs for troubleshooting out in the field?
Uh, To be honest with you, not out in the field, but they are very handy for walking customers through stuff over the phone. You'd be surprised how many customers do not carry a multimeter with them. So by being able to walk somebody through diagnosing station keys, power, all of that stuff over the phone by just looking at LEDs is a game changer.
Yeah, and on that note, in my communication training, we talk about how to trace the power without a voltmeter, because again, almost nobody has one. Surprisingly few people will say yes to that question. And so I talk about how we follow the lights, right? First, we check the light on the panel, see if the board has light. Then we check the lights on the board and the LED diagnostics on the board, so we know whether the power is making it past the fuse. And then from there, we have to do some additional diagnostics.
Yeah, and actually, you brought up a good point, because that's another thing too. I can't tell you how many calls I've resolved by sometimes, people forget to connect the ribbon cable to the command module, right? I've seen that a lot. And so, right, they think the controller's messed up or something, right? And then, like Ben said, I'll look at the display on the command module.
So the one last thing that I want to highlight before we move on is the LEDs that we see for running stations. So if I back this guy up and you can see what I'm doing on the panel, right down here, I'm going to turn on a station and I'm going to let you see what the LEDs do on the board. So
all right, so we're
turn on a station, and then
when you
the
turn on a
corresponding.
station. Oh, go ahead.
I'll just turn on a station, and then the corresponding LED light will turn on to tell you which stations are delivering power to which ports. And this is a valuable diagnostic step, right?
Right.
Absolutely. When I'm in the field, first thing I say is the LED light on? Because a lot of times customers will say, well, I turn it on from the clock, but your clock's broken. It's not turning the station on. Well, is the LED light coming on? If the LED light's coming on, then most of the time you have power, and you have power going out to the valve. So your issue is not the controller. Another thing that I use the LED lights for is finding bad commons. What will happen is if you have a bad common wire, bad common connection, the power is going to go out on the station level. But if it doesn't have the path to come back on the common wire, because maybe the common wire is broke, it'll actually jump across solenoids and come back and actually reverse light some of the other LEDs.
Christmas
so the
tree
way I
style.
see that happening is you'll get like 4 or 5 LEDs come on at once. And that helps me troubleshoot that too.
That's awesome. Yeah. Great.
Yeah, and you make a valid point on that, TJ. One thing I'd like to add to that, Ben, real quick, is don't freak out on your initial power up on the controller. 15 seconds after you power it up and it initializes, you're going to hear a click, and it's going to run through however many active stations you have, right? So it's going to click, 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 and you'll see those LED lights turn on one at a time. What it's actually doing is running a diagnostics, what we call a runtime valve test, to make sure that all active stations do not have an electrical alert, right? So they basically shook hands with the controller and we're good to go.
Right. That clicking is a feature, and one that you actually really like. Just
yeah,
don't
we
freak
like
out.
that.
Absolutely. All right. So that's the LEDs. Let's quickly talk about the ports that we see here. They match up just almost in sync with the LC. So I'm going to start with the valve wire terminal ports, because this covers 2 things, right? We have these. This is where we plug in all of our valve wires. At the end of the valve wires, we see black VC and a red FL1. Jonathan, what is that?
So your red FL1 is for your flow sensor, your first flow sensor in this case, POC1, positive, right? So my flow sensor positive, and then the black VC right next to it would be your ground or negative for the flow sensor. So positive
we call
and
that a
negative for flow
common in
sensor.
the irrigation world.
Right.
VC stands for valve common.
There you go.
Yes. One thing I'd like to point out, Ben, can you energize the master valve now that we're on flow sensors?
Sure. Let me go turn that on real fast.
And you'll notice the blue LED light, right where the red flashing light, the green, and the amber light is. We'll see a little blue light come on here shortly once Ben energizes the master valve.
I'm gonna.
And we can do diagnostics.
It's got to run the valve test because I just changed the master valve.
Right. So anytime we change that configuration, right, it's going to run that valve test.
You can see the LEDs running the valve test.
Mm-hmm. Which is normal.
You can hear it click.
Right. So we saw that last blue one kind of flash real quick. That's actually where the master valve indicator LED light. So don't get thrown off. If you see that, again, we can use that as a diagnostic tool, right, to know if my master valve is energized. Depending on the style of master valve you have, right, you can quickly isolate a problem if there's a problem.
Absolutely. All right, let's talk about ports. So,
one last thing. Sorry, Ben. Flow sensor. Where does the flow light live on this guy? It lives on the adapter board. Similarly to the LC, we have an electrical light, we have a flow light, and we have a comm light. If red, you have a flow alert. If red on comm, we have a communication alert flashing. On EL, it's an electrical alert. If my flow sensor is active, my white LED light for flow 1 will be flashing. Ben, do you want to illustrate how what that looks like, or?
no, we saw it on the LC.
Okay.
We're good.
All right.
So we talked about the flow ports and the station ports. What I want to know is, what is this guy up here?
Yeah, so that's my the rain switch that Ben is taking out is the same rain switch that we saw in the LC. Same functions, same everything. We all and they're even oriented the same. So left always red, right? Your first red will always be facing the left. The first red is 24 volt. The second red is your ground for that power, and then white and black for your rain sensor, which has a bridge, right? From factory. If a rain sensor is not installed, we want to use that bridge.
Nice. And then we've got this port right here next to the valve wire terminal strip that I don't recognize. We don't have
the
anything.
remote port. So that remote port is for connecting either a TRC or a ProMax remote to it. The reason why,
does Site One stock those?
Absolutely, we do.
Okay.
And we stock the cables as well. If a customer has their
EX cable,
absolutely. If a customer has remote of their own already, we can get them all of the equipment to get them up and running. So the reason why I would want to use a remote over maybe my phone app would be for doing something like wet check, or not wet checks, but like head flushes or something like that, to where, okay, I just changed the head out. I probably got a little bit of dirt in the line. I need to energize it, flush the line real quick, and then shut it off immediately. The remote is instantaneous. You can snap your fingers and it's done. Whereas the phone app, obviously it needs to go up to the cloud and then back down to the cloud. So there may be a few second delay. The downside is the range. Obviously it is run on low megahertz frequency. So you can't be sitting in Hawaii wet checking your system like you can with the app. But for in the field, running real quick for flushing lines, stuff like that. Awesome feature.
Yeah, the other thing I was going to mention is not a lot of our irrigation techs want to use their personal phones, right? Or have the ability to use the mobile app, right? And so this opens up a wider ability to help us address that issue, right? And so we can now have another tool to help us achieve the same goal in a different way.
That's perfect. And the thing that I would add is, by using the remote, you're taking power from the board and delivering it directly back to the board. So you're circumventing the panel, which means that only if you have flow sensing water starts running and the controller doesn't know why. So make sure that if you are using that remote and you have flow sensing, you put a master valve override on so you suspend those leak alerts while you're running through the remote.
Correct.
Tech tip.
That tip right there.
Nerd tech tip right there.
Super
That's like
nerdy.
extra credit.
All right. I think that's the only cable in here that we see is this guy hanging down from the antenna, right? This
Yeah.
guy goes inside the box. This nice little cable from the antenna attaches to the back of the panel. And if you ever catch that in between the enclosure and the panel, you can kink it, you can break it. So be careful. Treat that antenna wire nicely.
One thing I'd like to add to the antenna, the connection, there's a type of connector on the end of the antenna, and I get this asked a lot. What type of connector? What is this called? I'm trying to find, for whatever reason, you have to like route a longer extension. We call that in the electronic world, an SMA connector. Okay. There's an SMB and then there's an SMA. We currently, on all our modems have an SMA connector.
Okay. So anything to close out Pro 3, fellas?
No, I think we covered it.
Let's show that ground lug once. Awesome. Ground lug. Make sure that all of your controllers are grounded if possible.
Thank you.
Exactly. And then the transformer is designed to go to either side, depending on what you're up against in the field, right? You can just disconnect it from one side and reconnect it to the other.
Absolutely.
And the grounding lug is actually, you can move that from one side or the other depending, again, your configuration.
Opposite. I always put it opposite of the transformer.
Right.
Yes.
All right. Awesome. The H2O2 wire. So the boards look just a little bit different, but the diagnostic lights actually look very similar. So the concept of troubleshooting and using those LED lights is the same. We're just going to switch over to a 2-wire controller. You'll see I only have it attached with one of those finger screws, and it's just fine. It hasn't exploded at all. So we will leave that there. Jonathan, take me through it.
Yeah, so
down here at the transformer. Oh.
Okay, yeah. Transformer, both Pro 3 and the XR H2O use the same type of transformer, same configuration, same power options, standard from factory. And it works exactly the same way. You'll even notice that, Ben, if you zoom in up a little bit on the first circuit board on the upper left where our transformer is connected. So you'll notice that this is actually a similar design to our Pro 3, and so the transformer then feeds our 24 volts to our mini chassis, and we have the 24-volt light on our bigger board, right? Ben, it's on the direct connect board, 24-volt light, orange light on the right. Yep. So same thing. If we were to power down the controller, unplug the ribbon cable, and then power up the controller, we would only see the 24-volt light on the right hand side.
Okay. So we've got voltage here, fuse like we had on the last one, right? Power goes here, through here, and down into the board.
And then through that board, we then feed the board right next to it down at the bottom, both the direct connect options for our points of connections and our 2-wire path.
Right. So we see our LED lights that indicate power, indicate connection to the panel. That's what that 3.0 light is, or 3.6 light is. Have an exact same rain sensor port. So just the same as we see. Moving down, we've got this port that is where we connect our 2-wire paths. You can see that with the XR, we have 3 available ports for a 2-wire path. So you can slice and dice those 200 stations any way you like along 3 main paths. Then over here Jonathan, you want to talk about what we see on this board?
Yeah, so on the right hand side, that circuit board there is designed specifically for our direct connect or conventional connections. Those will drive your flow sensor and master valve. We have the ability to run up to 4 POCs on this guy, which means 4 flow sensors, 4 master valves, potentially, if you require that. And then we also have the ability to run 24 volts, and we have a rail there on the lower right hand side to accommodate the 24 volts if you need it.
Absolutely. And I would highlight that the system is capable of running 4 master valve and flow sensor setups. Direct wire is an option, so is adding that to the 2-wire path. So these ports would only be used if you direct wire those components, but if you add them to the 2-wire path, each one will require its own decoder. So with WeatherTRAK, that's an option. You can go either way, and you can even mix and match. TJ, do you see a use for 4 different flow sensor ports? How often do you run into that?
I see 4 flow sensors and master valves actually quite a lot, especially in a 2-wire scenario. Combining controllers into a single 2-wire controller, especially since we can go up to 200 stations now. We could essentially combine 4 48 station controllers into a single 200. And if each one of those controllers had a flow sensor and a master valve, we're going to need the ability for 4 flow sensors and master valve.
Yeah,
absolutely. And then Jonathan, last but not least, can you tell me what we see up here with the station keys? How come we need station keys on a 2-wire?
Yeah, so these again work just like the LC keys that we call these smart keys. These are modules that expand the controller from we can go from 48 to 96, or in case if you need it, we can go up to 200 stations. So those keys will expand our abilities to drive more stations, right? Those keys only open up station availability, right? So you increase the stations. Out of the box, all H2Os have the ability to run up to 4 points of connection without any additional components to the controller. And one last thing, Ben, for the direct connect, and TJ, correct me if I'm wrong, when installing, if possible, right, the preferred method is to physically wire or conventionally wire your flow sensor and master valve to the controller in case something happens to your 2-wire path. You still have controllability and visibility, and that's a great safety feature.
Absolutely. I prefer to actually, if possible, have my master valve and flow sensors direct wired.
Yeah. And again, and that's if possible, right? And obviously that's not always going to be a luxury we run into, right? So then we have the ability to hop over on the 2-wire side.
All right, fellas. I think that is about all that we have time for.
Dang, that was a lot, brother.
That was a lot. We got a ton.
I was trying to keep it short and sweet. Sorry, dude.
Trying to keep it short and
That's
sweet.
a lot. That's like, how do
know.
I explain this without like going too deep?
So I am going to real quick talk about what's coming up next. Again, we are dedicated to doing Smart Water Wednesdays the last Wednesday of every week. We got preempted last week because of a different HydroPoint webinar. If you saw the webinar last week, it was an amazing testimonial about the success of water management. So next week, or next month rather, I'll share my screen here real fast. I'm excited to share the upcoming event. We're going to have a customer success story about how WeatherTRAK mobile mapping is saving our customers time and energy. It's a great conversation about how WeatherTRAK saves something other than water. We're going to have Abby on as our special guest, and my friend Ed Hodnett, who is the sales rep for the Texas area, and it will be something to be seen. We'll talk about all of the different efficiencies that one of our big corporate campuses saves by using WeatherTRAK mobile mapping. So until next time, thanks everybody. Especially shout out to Jonathan and TJ. Thanks for making time. This was a lot,
Thank you for
but
having us,
super
Ben.
fun for the sprinkler nerds of the world. Thanks, guys.
Thank-
Thank you,
for
Ben.
being
Thank you,
on.
Jonathan.
Yeah, thank you, TJ. Thank you for being on. This was great. Thank you.
Absolutely. We'll talk soon, guys.
Alrighty.
Have fun.
Bye-bye.